Good morning and happy Monday. Hope you had a great weekend and were able to get outside and enjoy the weather before the snow came. I hope you were able to take your Unit 4.1 Week 1 quiz and submit your work for that on Schoology. So last week you worked all with the properties of quadrilaterals. So this week we're going to take a look at the proofs of those. So I'm going to give you a moment to get your note paper ready. Of course, always feel free to pause the video if you need or rewind. So we're going to take a look again at those properties that we used last week. Hopefully you've got those down and you were able to go on to the GeoGebra app and kind of investigate and discover some of these properties for yourself. So just to go through those real quickly, I'm just going to mark them as we kind of talk about them. But again, we started with the definition of a parallelogram, and that was just that opposite sides are parallel. But along with that came a lot of properties. For instance, those opposite sides were also congruent. We knew opposite angles were congruent. Both pairs of opposite angles are congruent. We also learned that the diagonals bisected each other, which means this got cut into two congruent segments, and this was cut into two congruent segments. We also know then that consecutive angles are supplementary. Any pair of consecutive angles were supplementary. So there was a lot of properties about just a parallelogram. Then we got a little bit more specific and looked at the properties of rectangles. Well, rectangles are parallelograms, so all these properties come along with rectangles. I'm not going to mark those. But our new properties, by the definition, it just has 4 right angles. And then we learned that the diagonals actually are congruent to one another in a rectangle. So then we went on to rhombuses. Again, rhombus, it's all those properties of a parallelogram, but its new properties are its opposite. Sorry, get that out of the way. Its opposite, all of its sides are congruent to one another. The diagonals bisect the angles, so that pair of angles gets bisected and this pair of angles gets bisected. The diagonals actually end up being perpendicular to one another as well. So because these are bisected, you see that we get 4 pairs of congruent triangles that are right triangles. So that was that for the rhombi, or rhombuses, whatever you want to call them. Then we got to the most specialized parallelogram, which was the square. It comes with all the properties of the rectangle, all the properties of the rhombus, and of course parallelogram in general. But now we have 4 congruent angles and 4 congruent sides. So that makes our diagonals actually turn out to be congruent. They bisect one another. They're perpendicular to one another. So we actually end up with 4 congruent isosceles right triangles in the square once we draw the diagonals in. So then we went on to the non-parallelograms, or the kite. Again, the kite was defined as having 2 disjoint pairs of congruent sides. And then we get these half properties. The diagonals are still perpendicular to one another, but one diagonal bisects the other. One diagonal ends up bisecting angles. And we have 1 pair of opposite congruent angles, so this ends up being congruent to that. I think we got everything there. And then we moved on to the isosceles trapezoid. Again, you only have 1 pair of parallel sides. And so it's isosceles because the other pair of sides is going to be congruent, the legs we call them. So we get some lower base angles that are congruent and also upper base angles that are congruent to one another. The diagonals actually turn out to be congruent to one another. I think we got everything on that. Oh, and we still do have consecutive angles that are supplementary. So an upper base angle and a lower base angle end up being supplementary. So all of those properties you now were able to use, and hopefully you have those all memorized. But again, you messed around in GeoGebra to prove those to yourself. But again, it wasn't really a proof. You might have been asking yourself, why? Why, just because it's a parallelogram, are its opposite angles congruent? I'm sure as good math students, you were definitely asking the question why. So we're actually going to look at some proofs as to why these things are true. You'll do some for homework, but we're going to do a couple of together. We're going to start with a nice short one here, where we have a parallelogram CDEF, and we want to prove that DCF, this angle up here, and CFE, this angle down here, are supplementary. In other words, those consecutive angles are supplementary. So we've got three lines to fill in here. Of course, you know the first one. So we're going to fill in our given. Just the fact that we have a parallelogram was all that we were given. But we know by definition of a parallelogram that these sides are parallel to one another, so we'll stick that in our proof. Again, think about what we're trying to do. We're trying to get some angles that are supplementary. Well, what do we know? If we have parallel lines cut by this transversal, that was from first semester. We know all about parallel lines cut by a transversal. We get some angles. So the angles we're interested in here, of course, this one and this one down here, those were called same side interior angles. So we have the two of them congruent just by our same side interior angles theorem. So that was a quick little proof, three-stepper, again, just based on those parallel lines. So let's step it up a little and move on to a little bit longer proof. So we got this guy here. So we've got a parallelogram, again, that's all we're given, and we want to prove that Km bisects Ln. In other words, that the diagonals of a parallelogram bisect each other. We know that's one of their properties. Let's prove why that's true. So again, we're going to start with our first reason, our first statement, of course. We've got a parallelogram. And let's do what we did last time. Start off with the same thing. Because the definition of parallelogram, we know we have some opposite sides parallel. So I've marked those parallel, written them in as my statement. So from parallel lines cut by transversals again, parallel lines, we get a lot of transversals in here. I'm going to go with, good old alternate interior angles. Remember those, that angle up here and this angle down here, and this angle and this angle. We've got some congruent angles just because they're alternate interior angles. So right now I'm hoping you're focusing on this triangle up here at the top and this triangle down here at the bottom. They have some things in congruent to one another. So let's see what else they have. Well, remember by our definition of parallelogram, we knew opposite sides are parallel, but we also had a property that says opposite sides are also congruent. Now those properties are actually things we could prove, so we should technically call them theorems, but I'm just going to state that opposite sides of a parallelogram are congruent. So now again, when I'm looking at my triangle, I had those angles, alternate interior angles congruent, and that side congruent. So if I focus on this triangle at the top and this triangle on the bottom, we now have enough information, 3 pieces of information, to say that the triangles are in fact congruent. So that's our triangle congruence theorem, ASA, got angle side angle matching angle side angle. Okay. And then why did we want to prove triangles congruent? Well, our very popular theorem, our CPCTC, would say then we get other parts are congruent. Well, which parts are we interested in? Well, I need to show that this diagonal bisects this diagonal. So I'm going to move on to this segment would be congruent to this segment, and LP would be congruent to PM based on CPCTC. So we had our congruent triangles, so other corresponding parts are congruent again. Well, I've got one blank left in my proof. So that's my proof statement, and just simply by the definition of bisector, I know that these two diagonals bisect each other. So 7-step proof, a little bit longer, but still not so terrible. So keep in mind as you're working through the proofs, trying them out, keep in mind we're dealing with parallelograms, so we can definitely use parallel lines cut by transversal to either get some congruent angles or supplementary angles, depending on what your proof statement is. You can use the definition of your quadrilaterals to gain some congruent angles or segments. And then we can always go back to proving triangles congruent, so we can use our CPCTC. So again, give it a shot. There are 6 proofs on the assignment page. I would try them just straight up on your own first, see where you get. If you don't get very far, we've provided a fill in the blank Same proofs, just we've given you either the statements or the reasons, and you just fill in the other. And then by all means, check your answer key after you are done. And if you have questions, don't forget to come to office hours on Tuesday, 9 a.m. in the morning, and ask some questions. We'd love to see you there. So go ahead, get started on the assignment, and see what you can do. Have a good week. Bye-bye.